Hello student, I'm Shruti ma'am. Welcome to our channel Shiv Academy 8. Today is our first lecture on circular motion. In this lecture we are studying about linear and angular motion, angular displacement, angular velocity and angular acceleration. So first start linear motion. Consider a particle P moving along a straight line, and at that time its displacement is x, and we call it as the particle is moving along a straight line, therefore it's a linear motion. Suppose this point P is the initial point. After time t it displaces at a point Q. This is its final point. So we call it as a linear motion. The particle's motion along a straight line is a linear motion. And the SI unit of this linear motion or displacement or linear displacement is a meter. And the CGS unit of the linear displacement is a centimeter. Suppose a curvilinear motion. Suppose consider the one car is moving along the curved path. Suppose this is our car and this car is moving along a curved path. At that point, at this position, the motion of this car is a curvilinear motion. Today we are learning about the circular motion, and the circular motion is the special case of a curvilinear motion in which body moves along the circumference of a circle. This is a circle and this particle P is moving along the circumference of the circle is a circular motion, or simply we can say that the motion of a particle along the circumference of a circle is a circular motion. This is the particle and the motion of this particle is along the circumference of the circle. This is a circular motion. Some examples of the circular motion is, first example is the motion of the moon around the earth. This is earth and the motion of the moon around the earth is a circular motion. This is the best example or natural example of the circular motion. Second example, the motion of the electron is around the nucleus. This is also natural example, and this is our nucleus and the electrons are moving along the circular path around the nucleus. This is a best example. These two are the best examples of the circular motion. Before knowing the angular displacement, first we must know the radius vector. A vector drawn from the center of a circle to the position of a particle on the circumference of a circle is called a radius vector. A vector drawn from the center, this is O is center of the circle, to the position of the particle. This P is the position of the particle on a circumference of a circle. This is circle's circumference. The condition is that the particle must along the circumference of the circle, and this vector drawn is called the radius vector. And this radius vector denoted by r bar, that is equal to delta s upon delta theta, where delta s is a small linear displacement. This delta s is a small linear displacement and the delta theta is a small angular displacement. And the SI unit of the radius vector is meter and the CGS unit of the radius vector is a centimeter. Dimensions. When we have to write the dimensions of any quantity, we write in the format of length, mass and time. Here is no any mass term or no any time term, only displacement is occur. Therefore, L raised to 1, M raised to 0 and T raised to 0 are the dimensions of a radius vector. Angular displacement. Angle traced by a radius vector in a given time at the center of the circular path is called as the angular displacement. This angle theta traced by a radius vector r in a given time at the center of the circular path is called as the angular displacement. This theta is the angular displacement. Here is P is the initial position at time t is 0. Q is the final position at time t. Theta is the angular displacement at time t, where r is the radius of the circle and s is the length of PQ. This PQ's length is s. Yes, angular displacement theta is equal to length of arc upon radius of circle. The length of arc s is s and the radius of the circle is r. Therefore, theta is equal to s by r and the unit of the angular displacement is a radian. The difference between the linear displacement and angular displacement is the in a linear displacement particle moves along the straight line and in an angular displacement particle moves along the circumference of the circle, and the unit in a linear displacement is a meter and in an angular displacement is a radian. Angular velocity. Angular velocity denoted by omega. The ratio of angular displacement to time is called the angular velocity, and the finite angular velocity is equal to omega is equal to theta upon t. Here unit of the angular velocity is radian per second, or we can write it as radian per second. Dimensions. When we have to write the dimension of any quantity, we can write in the form of length, mass and time. Here is no any length element or length term, mass term, therefore only time term is here and it is at a denominator. So when we put this denominator term at numerator, it becomes its power raised to become minus. So it's t raised to minus 1. So dimension of the angular velocity is L0, M0, t raised to minus 1. Angular acceleration denoted by alpha. The rate of change of angular velocity with respect to time is the angular acceleration. Suppose if omega naught and omega are the angular velocities at t naught and t, then the angular acceleration alpha becomes omega bar minus omega naught bar upon t minus t naught is equal to delta omega bar upon delta t. That is, and unit of the angular acceleration is radian per second square. The dimension of angular acceleration is L0, M0, t raised to minus 2. Let's we know the difference between average and instantaneous angular acceleration. It is average acceleration is the time rate of change of angular velocity. Here alpha average is equal to omega 2 minus omega 1 upon t2 minus t1. Here is the time, this time rate of change of angular velocity is a average angular acceleration. It is delta omega bar upon delta t. And instantaneous angular velocity is the limiting rate of change of angular velocity. That is alpha instantaneous is equal to limit delta t tends to 0 delta omega bar upon delta t. that is equal to d omega bar upon dt. This is the limiting rate of change of angular velocity, and it is the time rate of change of angular velocity. This is the main difference of average and instantaneous angular acceleration.